Tyler, how's it going? Your other classes? Yeah. Is it? Do you guys find it stressful at this time of year? It's getting there. Yeah. Yes. Yeah. So all your assignments are due, right? I see. Oh. Okay. All right. So with all 6 of you here, 5 of us registered. Am I waiting for one more? Yes. No. Do you want to play? Let's see. All right. So here we go. Start. Am I waiting for anyone? No? Okay, here we go. All right, 5 questions. How would you make this function more robust? Yes. Good. Yeah, default parameters, putting the equal sign is the right syntax. Good job. Who's T? Tyler? Nice. Now change that function so it receives the following object instead. So I'm calling the function like this. You're basically destructuring that object inside the parameter. Yeah, this one here. And yes, good. Yeah. Okay, so based on the last question, I guess I kind of led you on. Yes, you are using the REST operator, but the question said, what will it display? So I guess this one, although I guess it could have been that one too if I had chosen that. Yeah, that nice, elegant way to swap. Very good. And final. Yeah, so this is, yeah, so both red. All right, good. So winners, Connor, Ace, and Tyler. Grab your sticker and we can move on. Today is going to be a bonus kind of day, I have a feeling. I'm going to try something out that I've never tried before. We'll see how it turns out. You can give me feedback if you like that. Okay. Okay, so a couple of announcements first. I haven't marked the majority of assignment 3 yet, so I've only marked 2 people so far. That's all I had time for, so I haven't marked assignment 3. I still have to do that. Next is an announcement. I know last week I showed that teaser of the photo app. We'll do the photo app. We're not going to do that this week. We have a lot to do today, so I'm going to move that off to another week instead. So we'll probably save that for week 12 or week 13. I'm going to guess week 13 is my guess, because week 12 is busy too. Another announcement. Oh yeah, so remember how last week I introduced the whole reduce method for ES6, and it was kind of confusing because I had that whole inception thing happening. So I thought of this like the day after that, oh, I should have demonstrated like this instead, so it's more clear. So what I did was I went back to the reduce. So remember this one here? So this was the exercise where you were given this array, and you basically have to reduce in order to, you know, an object. So what I've done this differently was I introduced the debugger command so that you can see what's happening under the hood. So let's try this out. I'm going to refresh the page. And when I refresh the page, you should see what's happening under the hood because the debugger comes up. Oh, where'd it go? Refresh, 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 refresh. Oh my goodness. A tab, up, reduce, refresh, reload. What happened? How come it's not even? Yes, the debugger is there. It's not even. That's interesting. Let's try this. Hold on. File, open folder. That under week. When was it? there. I'm not sure why. Let's save that. Refresh. Oh, that's so weird. I don't know why it's not even. Am I doing the right file? Gmail reduce. Right. Yeah. Okay. Anyways, if it works for you, please. I'm not sure why it's not working for me. That's so weird. You would see the Chrome debugger, and then if you click that button to step to the next line of code, you can see with your own eyes how the looping mechanism works, and then you can see the variables, how they changed from one line after another. I'll try that again during the break. Next announcement. Oh yeah, so if ever you try to, get some kind of JSON data in your browser, and I know last class, I think Zihi showed me her JSON data, and all her JSON data was like in one line kind of meshed together. And I said, you know what, you should download this extension. So if your JSON doesn't look as pretty like this, what you could do is you could go to Chrome extensions and maybe open the Chrome Web Store rather, and look for JSON, some kind of JSON. And you could download this one, JSON viewer, or this one, JSON formatter. And so instead of having your JSON data look like in one line, all bunched up, it'll look nice like this. And you could even have arrows that collapse nested objects. So that's a nice little tool. Next announcements. There are no more after-class exercises starting today. So, and let me show you. What did I write here? Click link to show article. Oh, right. So I'm reading my notes. All right. So here and under week 11, I said here there are no after-class exercises. However, I'd encourage you to do as much free code camp as possible in the future. People who complete all of free code camp certificates are in demand and may lead to being hired with six-figure salaries. And I put a link here. So let me show you this link, this article. So this guy at age 30 started from JavaScript newbie to full stack. Now he was a programmer before, he just never did JavaScript before. And so in a nutshell, he started with free code camp, did free code camp certificate, free code camp certificate, and then in 1 year he ended up, getting hired with a six-figure salary. So may that be an inspiration to you and to me. So I said in the assignments, next to announcements, for assignment number 4, I displayed this video before, but I also suggested, you know what, if you want to make a blackjack game, so for this bonus here, create a dealer opponent who you can play again. It can be as simple as generating a random number, or it can be more complex. So let me show you my simple rendition of that. So let me find. I would begin game. Okay. So imagine I still had the assignment requirements of the show selected cards, show deselected cards, whatever it was. But here, okay, so I deal, which is kind of the same. Okay, I put a little animation, whoopie-doo. And then notice I'm also keeping track of the score. And I hope I get a complex one like with an ace or a couple of aces in the hand. Oh, okay. Anyways, and then when you choose to stand, it'll just generate a random number between like 17 and 20 something, and I either lose or win, whatever. So that's the kind of thing. What should I do? Hit or stand? Hit. Okay. Okay. So you lose. So there it is. So something as simple as that. Next announcement. Oh yeah. Okay. So check this out. Here's a tip. How long does it take for a computer to fetch a GET request across the world through the internet, as compared to just local code in your computer, running a function? So let me show you a cool tip. Actually, maybe what I'll do is, where's my no. What I'll do is this. So the question is, how long does a network GET request take in comparison to other things. So I'm going to show you a tip here. Console time. Console time allows you to basically have a stopwatch to see how long your code is taking. So how it works is you say console time, and you put in string some kind of unique string, so getting data, whatever you want. But whatever you put in here, you're going to need in a second later. So, so you enter that. Let's go fetch something. So let's go fetch the what I had before. Oh, I don't. So I'm going to fetch the JSON data from GitHub. Okay. Do the regular. You get some kind of response. You have to turn that response into JSON, so it's usable. And we can use data. So instead of the console logging the data, I'm going to stop the stop console time end, and then inside here is the exact same string that I had before. And I think that's it. And then as soon as I say enter to run the code, you should see how many milliseconds it took for this. So here we go, enter. 5 milliseconds. Try it on yours. Actually, the very first time. Try it on here. I want you to try this on yours because I think you're not going to get 5 milliseconds. I think you're going to get a bigger number. I think it's only 5 milliseconds for me because I did it before and now it's cached kind of thing. I want to see how long you guys, because I know the first time I ran it, it was huge, that number. So someone try this and tell me how many milliseconds they got. Anyone? I know Sihi's trying it. I'm thinking Suk is trying it, maybe. I don't know. No? No? Hold on. Okay. The whole point of this is dealing with asynchronous JavaScript. So unlike PHP, which is synchronous language, which, if you fetch some data from the MySQL database, it takes some time, probably the same amount of time as this. And then once the results are returned, then you store it in a variable, and then you move on to the next line. But JavaScript is not like that. What do you guys see? Anything? 77,000. How many? 777? 777. Wow, 77,000. That doesn't sound right. I know the first time I got it, I got like 500 milliseconds, but 77,000. That's crazy. Okay. But that goes to show you why we have asynchronicity built into the JavaScript language, and why we use this weird callback thing or the promises with the .thens, and we're going to get into that in a second. Okay. All right. So, we're going to get into now. Okay. So promises. So let me go back to this website that I showed you earlier. 10 things a serious JavaScript developer should learn. So this one here on number 1, you should know the core language. And I talked about how you should know all of this stuff here, including the truthiness, falsiness, how to work with JSON. And then here, you should know this. So now you know destructuring, you know template literals, and now we're going to move on to promises right now. So remember last week when I taught reduce, and I could hear your minds frying because it was very academic in nature and very theoretical, and promises is like that as well. So I expect you to bear with me, and I hope to make it somewhat interesting and practical so that you understand it more deeply. Okay, so why the need for promises And let me start with this code. Let's just open up something. I'll call it promises.html. Okay. Hi. Up in the browser. Promises. So let's revisit why we have promises in the first place. Because it's a whole dealing with the asynchronous nature of JavaScript. So question, I'm going to write a bunch of code. You tell me, does it work? That's it. Okay. Function, get data. I'm going to pretend it's getting data across the internet after 3 seconds. For 3 seconds. We'll return. There we go. So after 3 seconds, just pretend it returns an array with 3 text. I'm just going to fill in some stuff here. ID1, 2. Well, let's pretend. Let me just put some more just to make it look somewhat. Yeah, that's my pretend data. So that's right, I have a function. Question is, does this work if I say, once I'll say got data equals, I'm going to run this function. So console, instead of console log, I'll use console table, which I showed you last time. So question, show of hands, who thinks this will work? Yeah, shoot, Tyler. Okay, so let's save it. We'll run it. Works, right? Woohoo. Okay, I'm going to change the code. You tell me if this works. There's nothing asynchronous about that code. Now, I'm going to try to emulate the 3 seconds. I'm going to say set time out. Syntax, I always forget the syntax for this. So that, and then after, only after that, then I put the amount of milliseconds. So in here, in the body, I'm going to move all of this return statement inside here. So it only returns after three seconds. Okay. So now let me just see here. Data. Does this work? Yeah. The question is, does this work? Show of hands, who thinks this will work? Okay, let's try it out. So after 3 seconds, let's see what happens. 1, 2, 3. Uh-oh. That's supposed to. And that's the problem with dealing with asynchronous code. Because what's happening, if you look at this more carefully, because JavaScript is asynchronous, the way the browser or the way V8 works is, okay, I see this line of code. I see this function, which is, some code that I'm going to run. Okay, I'm going to move on to the next line right away. Right away. There's no waiting. But this network request takes 77,000 milliseconds apparently. So and JavaScript does not wait for anybody. Okay. So that's a problem. How to handle? If only there was some way to let JavaScript know that once the data is fetched 3 seconds later, then run this code. What's the solution to that? Oh yeah, we have something called callbacks. That weird thing in the function parameter that basically you put another function which kind of boggles the mind. That's how to deal with asynchronous code. So I'm going to rewrite this. Now I'm going to rewrite this code to try to use callback functions inside this parameter right here. So I'm going to write a function in there to handle this. So what's going to happen now is this. So let me see here. Let me start with this one. So this got data. First of all, I'm going to say this. Got data is okay. Well, then I'm going to call this function get data, but I'm going to pass it some code, which it will. I'll then tell the function get data, hey, once you get the data, run this code. That's why it's called the callback function. It doesn't run until it needs to be done. So how do you do that? You get the typical callback function, which looks familiar to you, but I'm hoping you'll get a deeper understanding of it. And then I can assign something like this. Right? So I remember probably the first couple of weeks of this class, you were thinking, what in the world? How in the world is this being populated? I don't get it. So let's look at that. So how do we change this? How do we change this function to accommodate this style of code? Remember, JavaScript can accept not only primitive values like numbers, strings, and booleans inside, but it can also accept other functions. So then we put in something here, some kind of variable here. So this is now representing this entire function. And if John was here to ask him how to run that function. So now how to run this function is this. I would now return, instead of returning an array, I'm going to call this, I'm going to run this function, which basically says, okay, once after 3 seconds you do get the data, which is this, my fake data, run my function, which is passed up here. Okay, so now I'm going to run that function. So return function, put parentheses, but inside the parentheses, I'm going to put data. So the question before you might have been thinking is, how in the world is this data being populated? Answer, oh, right there. Okay, so now, how does this work? I haven't changed, okay, I changed this a little bit, but the question is, show of hands, who thinks this works? Okay, we'll see. 1, 2, 3. Still one thing wrong. Anyone care to guess what's wrong? Why isn't that console table working? Because the console table is working, it's just giving me undefined. What's happening? And this goes back to my Tim Hortons analogy with the delegation of the kitchen. So right now, this is like making a panini because it takes 3 seconds. This is like ordering a tea because it's very fast. But this is the panini problem. The panini hasn't been made yet. What do we need to do with this line to make that show? Where should that be placed? Exactly, inside this. Now that we get this data, place that console right in it. So now after 3 seconds, okay. So this is an example of callback functions, which you've all used already, but I'm hoping that by looking at it from this angle, you'll understand more deeply how this variable is being populated and why we use this style of code to account for waiting. Because no other style of code that I know of can handle 3 seconds unless you want to wait for it. And if you want an example of waiting, all of you have probably went to appsanywhere.georgian. You click on something, and how long do you have to wait? Right. Okay. So in this above code, where is the callback function? Answer, it's right here. It's inside getData's parameter. The whole concept of promises is we don't want to write this style of coding of callbacks. It's kind of weird for our brains. We don't like to think in asynchronous nature. We like to think in synchronous nature. So we would like to print something like this. We want something like this. We want, ideally, we want something like const got data equals get data. Oh my God, if possible. But we can't have this right now because this takes too long. So we need some way to count for it. And that's why we have a callback function there normally. So here is where promises come in. I'm going to give you 4 definitions of promises that I researched. Before, I mentioned to you, promises are like a replacement of this traditional callback style. But I'm going to give you some other ways to think about promises. Number one, four definitions. Number one, promises is like an event listener, which you already know, on which you can register to listen for an event that lets you know when a task has completed. It's an event that will only fire once. Okay, that's kind of like the fetch, right? It only gets that JSON data once, and then that's it. Second definition, promises are like an IOU container or a future value. It's time independent, and it's a time independent container that wrapped in a value. So what I've heard other teachers say is that promises give you an object that you can work with, even if that object has yet to be fulfilled, even if that thing is still being waited upon. You can still work with that promise object, which is nice, because then it looks kind of synchronous almost in your code. Third definition, I like this one. Promises are the async version of a function's return value. So instead of having like a traditional function, and then at the bottom you say return, blah, 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 that return, that could be asynchronous now through promises, right? So that's what we kind of have here. And the fourth definition is promises provide order, predictability, and trustability. If you ever listen to the JavaScript guru Kyle Simpson, he will say something like, he doesn't like the callback style because it inverts the control. You don't have control anymore. You're just kind of waiting for things to happen. But with promises, the inversion of control is now back to you. You can actually handle a promise object now. You don't have to wait until something happens. So those are 4 definitions. So how to create a promise? Let me show you. Erase everything here. So I'm going to show you just a very bare bones minimal how to create a promise. Okay. Keep in mind when I said fetch blah 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 then fetch uses promises. So I'm teaching you how to make promises now, your own fetch if you want, that kind of thing. So this is how you do it. So let's say let promise equals, and then you say new promise. Okay. Now here's the weird thing. When I first learned this, I had to wrap my head around this. If you thought reduce was weird, because remember how I said for reduce, keep your mind on the accumulator, because the accumulator is like your lifeline between all the dreams. So for this one, this is weird, because these parameters here, resolve and reject, they're not just values that they're not that. They're actual functions. So inside this body of the code, I'm going to type in a second. And here inside this body of code, I'm going to actually call resolve, because resolve is a function, or I could call reject. Okay, so think of these as functions, because they are functions. So what's going to happen is when you get the data, let's say you fetch the data and you got the data, then you're going to say resolve and then pass in the data. That's it. This allows you to then have a .then after your stuff. Saying resolve data, that allows you to now have a .then. Because now we're using promises. Okay, so anyways, so this is just a hypothetical thing. If promise kept could be anything, right? You fetch data, then resolve, whatever. This could be anything, a string, data, whatever, right? Else, reject. And inside the reject, you can say new error something and pass in your error, whatever. This is the template of all promises. How would you use this? So you'd then go like this. You'd say promise.then, etc. That's how typically you would use this, high level overview of how to use this. Okay. So question, how would you apply this template to our get data function that we had before, which I already erased? So what I'll do, let me copy this for a second. Undo. So I get my function get back, and then we'll apply the template to so here's our template. Let's see how it'll look now using the promise. Okay. So this is what we're gonna do. This is what I'm gonna do. I'm gonna change this up. So I'm gonna say I'm gonna move this one up here at the. I'm going to do this. Let get data equals new promise. Function reject. Then inside here, I'm going to have my set timeout. And then, oh yeah, resolve. I have to resolve it. So after this thing, instead of returning, remember how that definition of return is like an asynchronous return. So instead of saying return, you say resolve. Resolve is a function. I'm passing in whatever data I want. Then how would I use it? So here, forget this for now. How would I use it? Answer data dot then. Then similar to our fetch, you have some kind of value. And then say, now that I have some data here, so value will contain this, I can now say, okay, assign my let variable up there. Save this, let's run this. So what I would expect is, as soon as I refresh the browser, in the console, I'm going to constantly type got data, enter, got data, enter, got data, enter. And you're going to see the first couple will be undefined because the panini is still being made. But after a while, it's going to give me the panini. All right, here we go. Let's try this. So here, refresh. Oh, refresh. There we go. Data undefined. Again, undefined. Oh, there we go. With that. So the first time it didn't have anything because it was still being made, and then the final 3 seconds later, I got something. Whereas the very first time, if you remember, it was undefined and I got nothing back because there was no way to account for that. But now there's a way to account for that through promises. So that's why promises were. Okay. So let me just switch my screen here so I can see something. So if you were to compare the old traditional callback style versus the promise style, again, our goal, if possible, is to write something like this, which looks nice and synchronous. Promises now looks like this, which is what I just wrote. And note, this is how we get, and note, this kind of looks a bit better, right? It's getting closer to this, kind of. But it's better than the old callback, traditional callback, because your mind can at least grasp this, at least. Note, side note, this is the only way we can get data out of the value. So this has to be declared somewhere else, and then you can fulfill this. Okay. Another side note, remember last week I taught you about async await being the newest way through like something like this, async await. Now compare our ideal dream of writing like this to async await style, writing like this. And this works, by the way. This code works. It's the async await style. So notice async await calls get data, but get data itself is based on a promise. In fact, async await is built on promises. It just happens that the style of writing the code in async await is much nicer, right? Because this looks a lot like this. And that's why people are gravitating toward async await style instead of the old callbacks, instead of even the newer promises. Because promises and generators is what makes async await happen. Okay. Let's see here. All right. Okay, so what time is it? Should I go through this? No, I'll just show it. I don't want to go through that. I'll just show it. So what I was going to do was this. Oops. I was going to show you, remember last week I was showing a million different ways to send, to get a GET request. So this is one of those ways. So this is the old common XML HTTP request, right? I created my own fetch using promises on this code. So I took this code, made a new promise and returned it, and resolved. So after I did all of this, which is the same thing as above, I basically resolved it here, resolve it. So once this happens, once I get the JSON data, I return it or resolve it. This works. So this, and to use this, you'd say my fetch, pass in the URL, and then have a .then, just like the real fetch. So that's kind of what is happening under the hood for fetch. Yeah. So on to assignment number 4, deck of cards. Okay, so I said for assignment number 4, you're going to use this. So everything that is happening today is going to help you with assignment number 4. And I kind of showed you a little bit of that during the first half of the semester. So everybody go to Google Deck of Cards API. Google Deck of Cards API, you'll see the first one here. Click on that. And I'll show you how it works. I want you to try this. Okay. The first thing you need to do is go to this API here. So I want everyone to try this. Copy that, open up a new tab, paste it in, press enter. Try it. Okay. So you should get something like that looks like this. Just as a interesting side note, let me try that using REST client. Remember the REST client extension I showed you in VS Code earlier, where I could say get some kind of URL, and then I click on the send request, and I get stuff back. Here's the stuff that's back. So here's the header stuff that we never see, but the browser sees it. And then here's the actual payload, which. Okay, so what's going to happen is, notice that when you went to that API, it gave you this unique deck ID number. Notice in the documentation that to draw a card or to do anything from here on in, you go to some API, but then you have to insert the deck ID number that you got into that URL to make that work. Okay, so I'm going to manually show that show that right now. So obviously, if I just copy this, it's not going to work because obviously I haven't inserted the deck ID yet. So I'm going to use what I got from here, which is only available for a limited amount of time. I'm not sure how long. And then I'm going to paste it in here. So now this should work. If I go to this, enter, there. I got 2 cards. One card right here and another card below that. So 6 of hearts, 5 of clubs. It gives me a link to the picture. So I could use this URL to link to a picture, right? Okay. So I did that manually. Your job right now for the next 10 minutes is to do that programmatically. Okay, so here's your challenge. And you can use fetch for this. And Google that up, MDN fetch. Where is it now? Sometimes I find MDN's documentation confusing because gives me this, but then that's not the one I'm looking for. I'm using for, oh, there, this one, using fetch. There, can be your template. Okay, so your job is this. Write a function called init to initialize, so that in that function it uses fetch to go to that first API I showed you so that you can grab the key. Once you get that key, actually, we'll just stop it there. So just do that. So write a function called init. Take 10 minutes to go to that first API of deck of cards, and you're going to try to grab the key and assign it to some variable, some global variable. Okay? So try that for the next 10 minutes. All right, so you're going to copy this kind of thing. Can I type in here? I think I can. No, I can't. Okay. You're going to replace the API with the first API that I showed you, and so on. Because this is the trickiest part, trying to get that API out of the promise. So try that. Probably don't need 10 minutes, probably need 5. Maybe 5. Put on the timer. By the way, today's class, I've designed it so that it'll have a bunch of 5-minute exercises, pretty much the whole day, to help you with this assignment. Got it? Oh, you're good? Okay. Anyone get it? Anyone? Anyone got it? Yes, no? No? Okay, so take it up. So using the template provided from MDN, let's do this here. What is this called? All right, so let's do this. Let's try it out. So it says the very first thing is to use this. Okay, so I'm going to copy that URL. And say fetch. Oh wait, function. It. Then I'm going to call that function, so don't forget. Okay. So inside that function, I'm going to fetch. Fetch what? Fetch that URL that I just copied. And then you're going to say .then. So the way it works is you get some kind of response. You can put anything you want there. You can put data. It doesn't matter what word you use there. But what you're getting here is an object, a response object, and that's why we have all response objects have this method called .json on it. And then you finally get the actual data that you can now console log. So, oh yeah, we need to assign that to a global variable. So let me say let and equals some array. Then here, because I'm using an arrow function and because I want to have multiple lines of code, I now need to use the brackets. And I'll say here, so what's the line of code if I want to push this data into my array of hand? What's the line of code? Oh, you know what? I'm totally misleading you. We're not there yet. I look at my notes. Say, oh wait, I have to do this. Okay, and then so what if I want to make this the ID that I received? So what's the next line of code? Right there. What do you think? What do you think, Tyler? Well, I got this data. So this data, let's say, is the JSON data that has the deck ID I want inside that object, right? So I have the data. It's inside. So imagine this is, is an object that has deck ID of some number, right? That's what that is, right? So I want to assign the deck ID to my API key so I can use it for future. No. So well, I guess you. Yeah, I just want the deck ID in here in this variable. What do you think? How would you normally do it without the destructuring and fancy stuff? Yeah, yeah. Yeah, so imagine the data has deck ID, blah, 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 right? Along with other whatever objects. I just care about the deck ID, so I'll just leave that. So how would you normally, if this is represented by the variable data, how do I grab? Yes. Okay, now I want to assign that to here, so I just say what? I want to know. So now, if I run this code, in the console, I type in API key, I should see proper key. What did I do? Oh yeah, so this is the result of console logging, right? And if I say API key or console log API key, same thing. There it is. Got it. Now I have the API key from which to carry out further requests. Great. So now, your next step, now that you have your ID, I want you to practice now drawing one card. Okay, this one draws two cards because the count is 2. I just want you to change that to count as 1, so it just draws one card. Okay, so create your new challenge is this. Create a new function called deal. That draws one card and outputs it on the console. Outputs the JSON data in the console. So that when you run it, when you refresh the page in the console, if you type deal, parentheses, enter, you should see the JSON for that one card in the console. Okay, so next, another 5 minutes. Try that out. Try that out. Another 5 minutes. Maybe I'll write the instructions here just so that you'll a reminder. The font size 72. That's your goal for the next 5 minutes. Create a function called deal that fetches one card and outputs that JSON to the console. Anyone get it? Yeah, you got it? Awesome. Tell me what you did for the function. Yeah. Okay, what'd you do? Yeah. And then you use that second API, right? Get that? You don't have to say it. Card. Okay, there it is. I copied it. I'm going to say fetch, paste, but I'm going to change that 2 to a 1. Oh, yeah. Sure. Yeah, thank you. Of course. Makes perfect sense. Okay, so we're going to pass the API key in here, right? Red $, square brackets, and then, right? And then what? We can just console it. Maybe I'll just rename this card. Okay, that should work. Let's refresh in the browser console. I'm going to physically type in deal to run the function, and let's see what happens. Here, refresh, and run the function deal manually, and I should see the JSON for one card. So, and it. Oh, here it is under cards. So it gives you this structure that looks like similar to the other one, but it has this cards array, which in there now I have the ace of diamonds there. So if I run deal again, do you think it'll add to this cards array? I think it should. Let's try it again. Say deal again, deal again. So there should be 3 cards in there. Let's just expand it to see if that's true. Here's the cards array. Oh, you know what? It didn't work. I don't know. Oh yeah. For sure. Yeah. No. Yeah. I'm thinking ahead already. Okay. Forget what I just said. That's correct code. That's the expected behavior. Good. The final challenge for this is this. Simple. In the HTML and in the body, add a button. That's skill. Okay. So that now in your JavaScript code, make that button call your deal function, and then you'll see the JSON in the console. So 1 line of code. You don't need 5 minutes for that. How do I do that? 2 lines. Yep. So const button equals document.query selector get the button, and then you said add event listener. Click, and then what's the magic? What's the name of the function? Deal. That's it. That should work. Let's see what happens. So each time I click the button, I should see in the console 1 card. That's the correct functionality to expect. Not what I was thinking before. There's my button deal. If I click on deal, click, I get a card, Jack of Hearts. Click on deal again. Here's another one. I get Ace of Hearts. Good. That's 1/2 of the assignment number 4. So we're going to take a break, meet you on the other class. And then our next challenge will be this, so I'm going to stop this exercise. I'm not going to continue along with this exercise, but to give you the answer to assignment number 4 and to also challenge you, I don't want to give you just the answer by using this because that'll be unfair. I'm going to give you another challenge, which is the purpose of this one right here, the emoji search and select. So I actually recorded myself today. So this is what we're going to create in the second half of class, like this. So you have this. You type in some word, which brings up all the emojis associated with that word. You're going to click the ones you select. The ones you click on will highlight it. Click on the button. It'll just show the ones you highlighted. You type in another word, for example. Now, this word differs from the assignment, but I'm sure you could extrapolate what you need for the assignment. And there you go. So now it's a cumulative effect. Okay. So that's what we're going to do for the second half of the course. We're going to do it in the same style of 5-minute challenges each. However, this is where at the beginning of the class I said I'm going to try something new. So I've never tried this in any of my classes before. I just thought of this brainstorm idea for teaching. Who here, show of hands, who's seen the show Amazing Race? Oh, but okay, who knows the premise of Amazing Race? Okay, so the premise of Amazing Race is two people are competing against other couples, and they have to travel to different places around the world, and they're given clue number 1, and whoever can get there the fastest and reach their destination first can get the next clue. And it's a race. So if you can figure out the clue and do it the fastest time, then you win. So next half of class, I'm going to design it in an Amazing Race challenge. Sit in pairs. Use only one computer between you. Okay? And all of you will get clue number 1 at the same time. As soon as you figure it out, bring me your laptop, show me it works. I'll give you clue number 2. Etc. Okay? We're going to have 3 races, maximum of 3 clues each. So everyone can have a fair starting time 3 times in a row. Okay, kind of thing. So that's the challenge. So have a break, 25 minutes, each on the other class, sit in pairs. Cool. And everybody sits in class. Any questions?